Good morning or afternoon, as the case may be, when you see this, year 10. I don't know which class is going to be watching this, but I hope you find it helpful. Anyway, today we're going to be covering two things: surface area and volume of cylinders, okay? So I'm going to do volume first, and then surface area is a little bit more complicated. I'll do that in the second part of the video. Now remember, what was volume? Think about it. Volume is a measure of capacity, how much a 3D shape can hold. So, a cylinder check out drawing skills. Anyway, a cylinder is a 3D shape and it's also a prism. It is a circular prism. Again, try to remember what a prism was. A prism is a 3D shape with the same cross section. So if I was to put the cylinder through a slicing machine, I should always get the same shape, the same face. And what shape would I get if I was to put the cylinder through the slicing machine? That's right, it's a circle. So, the volume of a cylinder is the volume of a prism. Any prism is worked out in exactly the same way. So the volume of a prism is the area of the cross section times the length of the prism. So area of the cross section times the length. Now the cross section is going to be the circular base. So we need to find the area of the circular base, which is the area of a circle. And what was the formula for the area of a circle? No, not that. It was pi r squared. So the volume of the cylinder is going to be pi r squared L, where L is going to be the length of the cylinder. So, in my case, if I know that the radius is 6 centimeters and the length is 10 centimeters, I can now calculate the volume of my cylinder. So the volume is going to be pi times 6 squared times 10. So the volume is going to be 360 pi centimeters square. Remember, in the exam they may ask you to leave your answer in terms of pi, in which case you do what I've done here. So you just leave it as 360 pi, or they could ask you to round your answer to 3 significant figures, in which case you whack out your calculator and you would do 360 multiplied by, if I can find it, the pi button here. I get 1130.97 or other. If I am rounding to 3 significant figures, the answer would be 1130. So the volume, 1130 centimeters square. Remember, do not confuse significant figures with decimals. They're not the same thing. Hopefully that's clear enough. That's how you find the volume of a cylinder. Let's now move on to the surface area. I'm going to use the same cylinder for my example. I don't need this volume bit here. So, surface area. Think again, try to remember what the surface area of a 3D shape was. And remember, surface area only makes sense in the context of 3D shapes. The surface area was the area of all the faces added together. Well, let's think about this. How many faces does a cylinder have? Think about your tin of tomatoes or your tin of whatever tin, I don't know, sweet corn, a tin. It's got 3 faces. It's got the lid, it's got the bottom, and then it's got the curved kind of body of the tin. So it's got three faces, and if I was to get my can opener and open the can, the body of the tin would be a rectangle, and at the top I will have one lid, and at the bottom I'll have the other lid. This picture looks a lot funnier if you put the two circles at the same end, but I'm not going to do that because I'm not that childish. I suspect some of you might. Anyway, remember, we knew that's the radius, and it was 6 centimeters, and the length or the height of the tin was 10 centimeters, and this was 6 centimeters. Okay, so surface area, I need to find the area of each face, so I've got three faces and add them all together. The circles are easy, so the area of the top is just a circle, it's just pi r squared. So pi times 6 squared, 36 pi. And the area of the bottom is going to be the same. So pi times 6 squared, 36 pi. And it's all centimeters squared. Alright, now I've got to worry, because the problem is I've got the rectangular body of the tin. Now we should all know that the area of a rectangle is the base times the height. Well, I know the height is 10, but what's the base? What's the length of the rectangle? If you think about it, this bit here, that length is equal to the circumference of the circle. Let me illustrate this with a piece of paper. This paper is creased down the middle, but hopefully you'll get the idea. If that was that's not a very good cylinder. Here we go. So if that was the cylinder, this is a circle, hopefully. That looks more like a circle, maybe, right? So that's the base of the cylinder. If I cut it open, that would be, so that would be the length of the circumference, isn't it? Because if I fold it back on, there you go, this is better, isn't it? That would be the circumference, and if I open it, that's the length of the cylinder. So this bit here, this is my red pen, this is my black pen, that there is the circumference, which is 2 pi r. So the circumference is 2 times pi times 6, which is the radius, so it is 12 pi. So the area of the rectangle, is the base, 12 pi, times the length, which is 10. So I get 120 pi centimeters squared. And if I add all of them together, 36 plus 36 is 72. 72 and 120, I get 192 pi centimeters squared. And I'm going to tell you the same I told you earlier. If they ask you to give your answer in terms of pi, 192 pi centimeters squared. If they ask you to give your answer in terms in three significant figures, you multiply 192 times pi and round accordingly. I just thought that earlier when we were calculating volume, I said centimeters squares for the units, so that would have been very wrong. The units for volume are cubed, so whatever I did before was fine, but the units should have been centimeters cubed, not centimeters squared. Anyway, I hope this was helpful. My recommendation, watch it, pause it, rewind, take notes, copy the examples out, and then have a go at the questions. Let me know if there's anything else I can do for you. Practice, practice, practice. Bye.